Hello, everyone. Welcome to the Unit 3 seminar on collecting like terms. So I'm going to show you the concepts you need today in order to prepare for your first algebra test on collecting like terms. Now, when we talk about a term, you have a coefficient part of the term, that's the number part, and the letter portion of the term that also might have an exponent, like the term that we have on the screen right now, 3x squared. The x squared is the variable, and the 3 is the coefficient. Now, because this term is not separated by a positive sign or a negative sign, we call that a monomial. Monomial has one term. So, for example, the constant number 5, even though there are no variables with the 5, it is still considered a monomial. 4xy squared. We have two different variables, the x and the y squared, and the 4. But because the 4, which is the coefficient part, and the variables are the x and the y squared, they are not separated by a positive or negative sign. So that still makes up a monomial, one term, even though we have three different components. Negative 2x squared, just like the 3x squared. This would also be another example of a monomial, but because we have the exact same variable, the x, and the exact same exponent, x squared and x squared, these would be like terms, and we could actually combine the positive 3x squared with the negative 2x squared. That is something we will do later on, but negative 2x squared by itself is a monomial, one term. 6x is also a monomial. The 6 is the coefficient and the x is the variable. Now, very important to note to yourself, x to the power of 1 and x to the power of 2 are not the same. Therefore, they cannot be combined. These are not like terms, these are different terms. And you will have known that if you went to my seminar for this unit earlier on. So x squared and x are not like terms because they don't have the same power. 8y by itself would be a monomial. We could not combine 8y with 3x squared because our variables and powers are not the same. Same thing with negative 4z. However, if I put two of these monomials together, we would get a binomial. So binomial means two terms. So for example, the expression positive 8y and negative 4z together, because the two terms are separated by this negative sign, that would be an example of a binomial, positive 8y minus 4z. If I wanted to take 6x minus 4z, that would also be another example of a binomial. Or take the 6x and combine it with my constant positive 5. We have two monomial terms separated by the addition sign. Together they become a binomial, the expression 6x plus 5. And finally, I could maybe bring my x squared down. So negative 2x squared plus 5x. That would also be an example of a binomial. A trinomial consists of three terms. So if I took my negative 2x squared, my positive 5, and then brought down a third term, oops, the positive 4xy squared, together, you can see that these three terms are separated by this addition sign and this addition sign right here. So 1, 2, 3 terms connected together, that would be a trinomial. Okay, so that's one possible item that you could be tested on, labeling terms as monomials, binomials, and trinomials on your Unit 3 test. The next component that we're going to talk about is the degree of a polynomial means multiple terms. Now, I know this particular polynomial is a trinomial. I have 1, 2, 3 terms, 3x squared plus 2x minus 8. Now, if the question is asking you to identify the degree of your polynomial function, you're always going to take the degree of your leading coefficient, or the term that has the highest power. So for example, this would be a degree of 2 because the highest power of all the terms is the power of 2. So for this particular question, my leading coefficient would be 3, and the highest power would be a degree of 2. So the whole polynomial function would have a degree of 2. So I prepared a little chart here. I'm going to zoom in on this chart. I have 2x squared minus 3x plus 4. We have 3 different terms attached together, so that would make this particular example a trinomial. And the highest power is a degree of 2, just like the example we just did. X to the power of 8 plus 5x. The first term is x to the power of 8. My second term is positive 5x. Those two terms together make up a binomial, and you can see that the largest exponent is the power of 8. That means the degree of the polynomial function is 8. Now for the third polynomial expression, a little bit tricky here, I can see that I have the coefficient negative 1/2 x to the power of 3. Now x to the power of 3 is larger than x to the power of 2. So because of that, maybe I'm going to use my little tools here. So I'm going to take my highlighter and highlight x to the power of 3. That is why the degree is 3, but I have 1, 2, 3, 4 terms all together, and that's what makes this a polynomial function of 4 terms. I'm just highlighting my highest powers in each case. For the next example, I have 2 terms, which makes this a binomial. Now, you'll notice that x is by itself. So when you have an x by itself, that means x is to the power of 1. So my degree is the power of 1. 9x to the power of 5. That is 1 term, because you notice that polynomial does not have any addition or subtraction signs separating different terms. So we have a monomial here, and because x is raised to the power of 5, the degree of my equation, my function, is power of 5. And finally, I have a constant number that does not have a variable or any powers. So it is a monomial that really tricks students on tests. That is still a monomial, but the degree of my monomial is 0. So please study this chart carefully before your next test. So now we're going to talk about combining terms or collecting like terms. So here I have an equation, and maybe I want to, when I'm doing my steps, this is my question, but I want an equal sign for every single step of the equation. And I've color-coded my algebra to help you a little bit. So to identify like terms, in your homework, if you have highlighters, please highlight the terms that are the same. So for example, 5x, x is the power of 1 in the term 5x, and 2x also has x to the power of 1. Positive 9 is a constant number, so it is not the same as the 5x and the 2x. So 5x plus 2x, adds up to 7x. Gonna get rid of this. And the positive 9 does not have anything to add to. So my final answer would just be 7x plus 9. Okay, so we have one type of like term, the x, and then the constant number. For the next question, I have a lot more terms. You can see I've highlighted x to the power of 1 in green, y to the power of 1 in pink, and z to the power of 1 in blue. Now, before I do anything, and on your test, you are not going to receive full marks if you go straight from the question to the answer. You do need to show a step where you rewrite the question so that all the like terms are next to each other. So you can see that I have written this as positive 3x plus 5x. I put them next to each other because they are like terms. The positive 2y and the 7y I have written next to each other because they are like terms. And negative 3z and positive, remember positive z, the coefficient is actually positive 1z. And notice when I'm moving the 3z, the negative belongs to that term. So the negative has to come with it when you are rearranging. The positive belongs to the 2y. The positive belongs to the 7y. If you don't move the sign in front of that term, you're not going to get the right answer. So now when I combine like terms, and you can do this in your head or on scrap paper, I know that the 3x and the 5x combine to 8x. 2y, positive 2y plus 7y combine to positive 9y, and negative 3z plus 1z combines to negative 2z. So my final answer is 8x plus 9y minus 2z. That will be my final answer, showing how I've collected like terms. This also shows you why you need to remember your integer rules from Unit 1. If you forget your integer rules, you're not going to be able to combine the like terms properly. So math is cumulative. Everything we learned in Unit 1 and Unit 2 has to continue in Unit 3. Okay. So usually, I just wanted to touch on this a little bit. Usually I would rewrite the question with all the like terms next to each other, but you can see 7q and minus 3q, you have to have the same letter, same power. 5r and positive 5r. The negative belongs to the 4, so negative 4 and negative 3 combine to negative 7. The positive 3s is the only thing that doesn't have another like term, so it has to just stay by itself as positive 3s. That's just like a tricky question I threw in there. Now, this is a very important question, so take a second to copy it down. I'm going to move that up a little bit. Negative 5x squared, positive 2x squared, positive 4xy squared, negative 2x squared, negative y. You can see I've used 3 different colors here. And this is a good example of why like terms have to have the same variable, same power. You notice in blue, the x to the power of 2 and negative 2, x to the power of 2. The x to the power of 2 is the same letter, same power, or same variable, same power. In green, the xy to the power of 2, xy to the power of 2, they can be combined because they are the same letter, same variable. Just want to show you one thing here. If I had the term, uh, 3, let's make that negative 3, x squared y to the power of 1. Okay? That could not be combined because the x would have to be the power of 1 y would have to be the power of 2 in order for it to be a like term with the greens. So that, in fact, is not a like term. Negative y is also not common with anything, so I'd have to keep it by itself. So the next step that we would do is rewrite all the like terms next to each other. The positive 2x squared, the negative 2x squared have to be combined together. And I know right away that positive 2 and negative 2 would cancel each other out. Those would cancel each other out. Negative 5xy squared and positive 4xy squared. Well, that would combine to, oh, I have the answer written right here, negative 1xy. The negative y would remain by itself. So my final answer would be negative 1xy squared, or you can leave it as negative xy squared, and then minus 1y. So that is a question you definitely need to understand for the test. I will make a part 2 for this video later on that focuses exclusively on questions that have different powers and higher powers with multiple variables. Okay. Here's one question I didn't do before. Positive 3x plus 2x plus 4x minus y. This is a simple question because I've circled in purple the like terms that are x to the power of 1 terms, and y to the power of 1 terms have been circled in blue. So I cannot reinforce this enough. Your very first step is to rewrite the question so that all the like terms are next to each other. You are not going to earn full marks if you don't follow that step. After that step, we combine our like terms. So the positive 2x, positive 4x gives me positive 6x, and the positive 3y minus 1y gives me positive 2y, and that would be my final answer. Our last question for this seminar is a nice long question. Okay, I want to give you a second to copy it. And when you're doing your homework, I would go ahead and use different colors to identify like terms. So for example, I can see right away negative 5x to the power of 2. I'm going to circle that in red. And I'm looking for another term that has x to the power of 2. And notice I'm not just circling 2x to the power of 2, I'm circling negative 2x to the power of 2. Because the sign in front of the term belongs to that term. And notice x to the power of 2 and x to the power of 1 are not the same thing. They are not like terms. So next in purple, I am circling all my x to the powers of 1s. The numbers in front of the terms, remember, are coefficients. They are not what we use to identify like terms. And finally, let's say in green, I'm going to circle all my constant numbers. So because I've used 3 different colors, that means I have 3 different types of terms, and that also means that my answer will have 3 terms as my final answer. So now that you've had a chance to copy that down, my answer should have something from the x to the power of 2. So I should have a component of my answer that has a variable x to the power of 2. Component of my answer will have x to the power of 1, and a component of my answer will have the constant terms. So you can see I'm going to take all of these like terms and rewrite them so they're right next to each other. All the x to the power of 2's, all the x terms, and all the constant terms are rewritten so they're right next to each other. Now I have to use my integer rules. So negative 5 minus 2 gives me negative 7 x to the power of 2. Positive 5 minus 8 minus 1 gives me negative 4 x to the power of 1. And positive 11 minus 15 gives me negative 4. So that concludes my introduction to the Collecting Like Terms seminar. Please proceed to do your homework and thoughtfully use colors and highlighters to help you identify common like terms and answer your your questions properly. Please make sure after every question or after every assignment to check the solutions to make sure that you're on the right track.